In this session, we're going to see more involving algebra of matrices, and in particular, matrix multiplication. Let's dive right in. Multiply the two matrices, 2, 3, 4, 5, and negative 2, 5, 3, 1, 4, 6. Here's the deal. Matrices have dimensions, and 2, 3, 4, 5, being a matrix that has 2 rows and 2 columns, is a 2 by 2 matrix. The matrix negative 2, 5, 3, 1, 4, 6, having 2 rows and 3 columns, is a 2 by 3 matrix. In order for matrix multiplication to be defined, the inner dimension, I think I made that up, but the inner dimension has to match. That is, in the 2 by 2 and the 2 by 3, the second 2 in the first dimension and the first 2 in the second dimension have to match. If that's not the case, then the multiplication is not defined. The way we're going to multiply is we're going to take all of the entries in a row of the first matrix and multiply them by all of the entries in the first column of the second matrix. And we're going to add together the products. Here's what that's going to look like. We're going to take that row 2, 3, and we're going to multiply it by the column negative 2, 1, like so. 2 times negative 2 is negative 4. And then 3 times 1 is 3. We add together those two products, and now we're done with that pair, that row with the first column. We're going to use the first row again, 2, 3, and we're going to multiply it by the column 5, 4. And so we're going to use 2 times 5, which is 10, and 3 times 4, which is 12, and then add those two together. Then we're going to do it again. We're going to take that first row, 2, 3, and multiply it by the last column of the second matrix, 3, 6. So 2 times 3 is 6, 3 times 6 is 18, and we add those two together. We're going to do the exact same thing next with the next row, but I want to point something out. Entries in a matrix are referred to by using a double subscript. And so the first entry in the first column is A11. It's true of all matrices, unless it's B11. The second entry in the first row is A12, where the first subscript refers to the row, the second subscript refers to the column. And so for the other one, we have A12 and then A13. When we take the first row, like we've just done, and multiply it by the first column of the second matrix, that's row 1 and column 1. That's where that landed, in A11 in the product matrix. When we took the first row of the first matrix and the second column of the second matrix, that landed in A12, and so on. Well, now that we have that, let's go ahead and do the same thing that we just did, but we're going to use the second row of the first matrix with each of the columns of the second matrix in turn. So we're going to take the second row, 4, 5, and multiply it by the column, negative 2, 1. So 4 times negative 2 is negative 8. 5 times 1 is 5. And then we add those two together. We take that second row, 4, 5, and multiply it by the second column, 5, 4. So 4 times 5 is 20. 5 times 4 is 20. And we add those two together. And then we take that second row of the first matrix, multiply it by the the third column of the second matrix. We have 4 times 3 is 12. 5 times 6 is 30. Add those two together, and that's the result of multiplying the two matrices together. But we can, of course, tidy this up a little bit. For the A11, negative 4 plus 3 is negative 1. 10 plus 12, 22. 6 plus 18, 24. Negative 8 plus 5, negative 3. 20 plus 20, 40. And then 12 plus 30, 42. That's the product of the two matrices. Notice that the product being -1, 22, 24, -3, 40, 42 is a 2 by 3 matrix. Remember when we said that the inner dimensions had to match? That is, in 2 by 2 and 2 by 3, the inner 2's had to match. The outer 2 with the 3 gives us the dimension of the resulting matrix. I know, cool, huh? All right, let's on to the next. Multiply -2, 5, 6, 4 by the column matrix x, y. Well, first we're going to multiply the top row by the column. And so we're going to take -2, 5 and multiply it by xy. We're going to end up with -2x plus 5y. Then we're going to take the second row, 6, 4, and multiply it by xy. And we're going to end up with 6x plus 4y. That's our matrix. Next, we're given 4 matrices. We're told A is the 2 by 2 matrix, 2, -5, 0, 7. B is 3, 1/2, 5, 1, -1, 3. C is 2, -5 halves, 0, 0, 2, -3. And D is a 3 by 3 matrix, 5, -3, 10, 6, 1, 0, and -5, 2, 2. We're told to find some values if possible, or some matrices if possible. And if not possible, say why. First, we're looking at AB. Well, it's good form to go ahead and write them together, and I have a little bit of difficulty if I don't do that step. So let me write down the two matrices, A and B. Okay, so now I have A and B next to each other, 2, -5, 0, 7, and 3, 1/2, 5, 1, -1, 3. So remembering that we use the rows of the first matrix with the columns of the second matrix, I want you to go ahead and pause the video and multiply these out. Okay, so my entries in the resulting matrix are 6 minus 5, 1 plus 5, and 10 minus 15. What do you mean minus? You said you were adding. Yeah, -5 times 3 is -15. And when you add -15, that's called subtraction. And then in the second row, we have 0 plus 7, 0 minus 7, and 0 plus 21. And so simplifying those is going to give us 1, 6, -5, 7, -7, 21. Noting that when we multiplied the 2 by 2 matrix by the 2 by 3 matrix, the inner dimensions matched, and the result is a 2 by 3 matrix. You notice that in the second row, well, two things. One, the answer is in brackets. The whole matrix was in brackets. That's because matrices have brackets. If you don't have brackets, it's not a matrix. I can't give you full credit. Number two, I notice that the second row, 7, -7, 21, is all divisible by 7. You don't get to divide anything out, though. The matrix is what it is. Okay, this is not an augmented matrix. It doesn't represent an equation. It has different meanings in different contexts. But if a whole row is divisible by 7, oh, great, it's divisible by 7. Not a thing you can do about it. Okay, next we're asked to find BA. So let me write down the two matrices. And B times A would be 3, 1/2, 5, 1, -1, 3, and 2, -5, 0, 7. If we try to multiply the first row of B with the first column of A, we'd have 3 times 2, and then 1/2 times 0, and then 5 wouldn't have a partner. Check it out. B is a 2 by 3 matrix. A is a 2 by 2 matrix. The inner dimensions, the 3 and the 2, they don't match. This is not possible because what I'm calling the inner dimensions don't match. And that answer is good enough for me. You're demonstrating to me that you know what's required. Let's look at what just happened here. We multiplied AB and we got an answer. We tried to multiply BA and it's not even possible. Matrix multiplication is not commutative. That is to say, if you're multiplying two matrices together, order matters. So it's a property of real numbers that like 3 times 5 is 5 times 3, and we always refer to those as properties of real numbers. And you were like, well, does and everything like that? And the answer is no. With matrices, you don't have that property. I know. All right. Next, we're asked to multiply A times C times D. So the first thing I'm going to do, write down those matrices. So I've written the matrices down. A times C times D is 2, negative 5, 0, 7 times 2, negative 5 halves, 0, 0, 2, negative 3. We're going to multiply those first because they're in parentheses, and then times 5, negative 3, 10, 6, 1, 0, negative 5, 2, 2. So we're going to one by one multiply the first row of matrix A by the columns of matrix C. And then we're going to multiply the second row of matrix A one by one with the columns of matrix C. I want you to go ahead and do that, pause the video, and then come back, and then we'll deal with D. So the entries of my product matrix A times C are 4, negative 15, 15, and 0, 14, negative 21. We blew right past checking to see if this was even going to be possible. Let's pause for a moment and do that. A is a 2 by 2. C is a 2 by 3. And since those inner dimensions match, we're good. And of course, we see the result is a 2 by 3 matrix. D is a 3 by 3 matrix. And so the inner dimensions of those also match. And so we're going to be good to go. Now let me go ahead and write down D next to our product of A times C. And notice I have to put it on the right because it's on the right in the original indication of what we're supposed to do. And matrix multiplication cannot be reversed. It's not commutative. So now we have 4, negative 15, 15, 0, 14, negative 21 times 5, negative 3, 10, 6, 1, 0, negative 5, 2, 2. We're first going to take the first row of the first matrix and multiply it by the first column of the second matrix, one by one. So that's going to be 4 times 5 is 20. Negative 15 times 6 is negative 90. And 15 times negative 5 is negative 75. Then we're going to take that first row and multiply it by the second column. And then we're going to take the first row and multiply it by the third column. And then we're going to take the second row and do the same thing in turn. So go ahead and do that and then come back to the video. And after all is said, I had to move it because I didn't have room. After all is said and done, we have the resultant matrix of negative 145, 3, 70, 189, negative 28, negative 42. This is an example of we can't possibly do this until we know what we're doing. But once we know what we're doing, it's not hard, it's just tedious, and it's really easy to make arithmetic mistakes. So this is just going to check your arithmetic and your organization. Next, if possible, find BD plus C. Well, let's go ahead and write down our matrices. So BD plus C is 3, 1/2, 5, 1, negative 1, 3 times 5, negative 3, 10, 6, 1, 0, negative 5, 2, 2, plus 2, negative 5 halves, 0, 0, 2, negative 3. Some things don't change, and in this case, it's the order of operations. We're to do the multiplication of BD before we add C. First, let's make sure all the dimensions are going to be okay. B is a 2 by 3 matrix. D is a 3 by 3 matrix. The inner dimensions match, so we have the product. When we multiply them, we will end up with a 2 by 3 matrix. C is a 2 by 3 matrix, and as you may remember, when you add matrices together, since we're going to do so entry by entry, their dimensions have to be identical. We have that so that the product and the sum are defined. Okay, so as usual, we're going to multiply the entries in the first row of B by the entries in the first column of D. And then we're going to take turns, the first row with the second column of D, and the first row of B by the third column of D, and so on. Go ahead and find the product BD, and then come back to the video. So the product matrix BD becomes -7, 3/2, 40, -16, 2, 16. And we're going to add to that C 2, -5/2, 0, 0, 2, -3. Go ahead and do that and then come back. Did you end up with -5, -1, 40, -16, 4, 13? Well, don't answer, I can't hear you. But if you did, there you go. Next, D times B. Well, I'm going to write the matrices down. So I've got 5, -3, 10, 6, 1, 0, -5, 2, 2, times 3, 1/2, 5, 1, -1, 3. Notice that D is a 3 by 3 matrix. B is a 2 by 3 matrix. So the inner dimensions don't match. This product is not defined. And that's what you're going to say. Don't say undefined, because that's, division by 0. I mean, if you say undefined, I'll be like, okay, whatever, but it's just more proper to say that it's not defined. Okay, now we're going to shift gears a little bit. Here we're presented with a matrix equation, and we're told to write it as a system of equations. The matrix equation is a 2 by 2 matrix, 2, -3, 1, 2, times the column matrix xy is equal to the column matrix 0, 7. This is commonly referred to as being of the form uppercase A times uppercase X is equal to uppercase B, right? The matrix equation AX equals B. We don't really need to know that now, but it's going to show up in a future session. So we're going to take the first row of A and multiply it by the column of X, and we have 2x minus 3y. Then we're going to take the second row of A and multiply it by the column of X, and get x plus 2y. So on the left-hand side of the equal sign, that forms our matrix. And on the right-hand side of the equal sign, we have the column matrix 0, 7. Now, if two matrices match, that means that their entries are equal. And so the upper row, 2x minus 3y, must equal the upper row of the column matrix of constants, 0. So 2x minus 3y equals 0. Likewise, we have x plus 2y is equal to 7. And in that way, we can represent a system of equations as a matrix equation. Well, all we were supposed to do is write it as a system this time, and so we're going to move on to the next. Yes, this is building up towards future stuff. Next, we have a 3 by 3 system, and we're told to write it as a matrix equation. 3x plus 2y plus z equals 8, x plus 2y plus z equals 5, and 2x minus y plus z equals 4. You may have this urge to try to solve the system right now, and you can do that, but it has nothing to do with what we're doing right now. What we're going to do is represent this using a matrix equation. I want to go back to the previous example. Notice that the matrix A that we had was 2, -3, 1, 2. Notice that the coefficients in the system that we ended up with were 2, -3, 1, and 2. Notice also that the variables that we had were x and y, and those are showing up in their appropriate places in the system that we had. And then finally, the constants were 0, 7, and that's on the right-hand side of the equal sign, 0, 7. It's important to note that anatomy, because when we have this system that we were just talking about, this 3x plus 2y plus z and so on, what we want to do is write this down in a matrix equation form, and that form is going to be AX is equal to B, where X is going to be a variable column matrix. A is going to be a coefficient matrix, and B is going to be our constant matrix. And so for our coefficient matrix, we're going to write down 3, 2, 1, 1, 2, 1, 2, negative 1, 1. The variable matrix is going to be x, y, z. And the constant matrix is going to be 8, 5, 4. All we were to do is express this as a matrix equation. You gotta be wondering why and what's down the road. We'll keep watching more sessions and you'll find out. If you wanted to make sure that what we've done was correct, then what you would do is perform the matrix multiplication on the left-hand side, equate them on the right-hand side. In other words, do what we just did in the previous problem. And that's it for this session.